the physical properties of a nitro compounds. Okay, I am taking nitro compound. This nitro compounds having pleasant smelling liquid. Whether they are soluble in water or not means this is sparingly soluble in water. Sparingly soluble in water. So, here water is acting as a polar solvent, but in water there is solubility as less, but completely, that is soluble in organic solvent like benzene, ether, benzene and ether. Okay, and comparing what is the reason for the less solubility and whether they are soluble in organic solvent. So, if I am taking nitro compound specially, this nitro compound is made up of a nitro group like this. This nitro group is like this. Whenever if I am taking this shifter, that is one of the pi bond is shifted to the oxygen, on the whole you will get N plus and O minus. There is polarity is creating. The high solubility in the high solubility of nitro compounds we are going to explain based on the boiling point. That is, if I am taking on the whole, that is sparingly soluble in water, but it is soluble in organic solvent. But if I am taking the boiling point is based on the polar nature of NO2 group. So, if I am giving a comparison, the boiling point of a nitro compound, that is high boiling point. The high boiling point of a nitro compound is due to the polar nature of the NO2 group. So, what is the physical property? Whether it is sparingly soluble in water or not. Yes, of course, it is sparingly soluble in water, but it is soluble in organic solvent. Like organic solvent, I can use benzene and ether. The boiling point of the nitro compounds depends upon the polar nature of the NO2 group. When the polar nature increases, the boiling point also increases. So, the nitro compound having more boiling point compared with the aldehyde and ketones. So, this is physical properties of a nitro compound. Next, coming to chemical properties. So, what is chemical properties? How this nitro compound involved in the reaction? If I am taking reduction, I can use it only in the two types for this aliphatic system. If the reduction is carried out in acidic medium and neutral medium, suppose if I am taking CH3NO2, that is first one as reduction. If I am taking nitromethane as an aliphatic nitro compound, there are two type of reductions possible. One is I can use acidic medium. Or I can use a neutral medium. Based on the reagent, there can be possibility for the different products. If I am using acidic medium reagent, like if I am using tin and HCl like acidic medium, I can use for neutral medium zinc in ammonium chloride reagent. What happened? What is the difference? Usually reduction means we are going to add a hydrogen. It is nothing but we are going to concentrate on the hydrogen. But if you are using acidic medium, there will be complete reduction. So, I am going to eliminate the oxygen fully and you are going to get CH3NH2 as a product. That is, the nitro group is completely reduced into amine group CH3NO2. So, CH3NH2. In addition to that, we have eliminated oxygen and that should be added as water molecule. This is one product. The name of the product is, this is amine. So, methylamine is formed as a product. Methylamine. And second type of reduction, it is nothing but partial reduction. This is complete reduction, this is partial reduction. So, if I am taking this here, how many hydrogen if I am added this NH2, here H2O. So, totally here if you want to concentrate 2 oxygen, so I should put 2 here. So, here 2 oxygen, here 2 oxygen, there are totally how many hydrogens we needed? 6 hydrogen. So, how to balance this? And same way, whenever if I am using neutral medium, there is partial reduction. So, how this? We will eliminate only one oxygen and we should add a hydrogen in the side, that is CH3. In that I have just here also I am going to add a hydrogen. So, CH3 NHOH. How many oxygen? Just we have eliminated means only one oxygen. We have added 2 hydrogen. So, that one oxygen added to form a water molecule, added with the hydrogen to form a water molecule, and this name N-methyl hydroxylamine. N-methyl hydroxylamine. Next, how to balance this? If I am taking this NO2, here NHO, like that. When I am taking this 2 oxygen, it is balanced, but I am taking hydrogen 1, 2, 3, 4. So, 4 hydrogen we should add to balance that reaction. So, first one is reduction, but reduction carried out in 2 different conditions. One I have used acidic medium and another one we are used as a neutral medium. So, this is the first method of properties. And second method, hydrolysis. Second method, hydrolysis. Generally, if I am taking a primary nitro compound on hydrolysis gives acid. If I am taking secondary nitro compound on hydrolysis, that will give a ketone. But tertiary compound, we are not using hydrolysis. That is not giving any product on hydrolysis. What is the reason? You know already, that is primary nitro compound containing 2 hydrogen atom, secondary nitro compound containing only 1 hydrogen atom, but tertiary compound no hydrogen atom. So, there is no reaction for the hydrolysis. Let me take a reaction. So, first one, primary, that is CH3 CH2NO2. This is primary nitro compound. You know what is the name for this? Nitroethane. So, this nitroethane on hydrolysis, that is acid hydrolysis. In the presence of an acid, we are going to add a water molecule. You are going to get the product as 2 carbon. So, 2 carbon containing acid CH3COOH, that is acetic acid. And what is the side product? That is special side product hydroxylamine NH2OH, and one more side product, again the same acid HCl going to be regenerated. So, the product is, one is acetic acid and another one is hydroxylamine, and the third one is a HCl. So, primary nitro compound on acid hydrolysis gives acetic acid as a product, depends upon. Suppose if you ask, Miss, why can't you take nitromethane? Yes, of course, nitromethane you take, you will get formic acid as a product. And same way, secondary, that is CH3C CH3HNO2. This is secondary nitro compound. So, primary compound will give acid, secondary compound on acid hydrolysis gives acetone as a product, CH3COCH3, because 3 carbon. So, 3 carbon, you are going to extract the product as acetone and side product as N2O, and you are going to get water as a side product. That is N2O means nitrous oxide. This is acetone and this is nitrous oxide. So, primary will give acid, secondary will give a ketone, but tertiary CH3C, CH3, NO2 because 3 methyl group added with 1 nitro group. This is tertiary, it is nothing but 2 methyl 2 nitro propane system. So, if I am taking this here, there is no presentation of a hydrogen. So, there is no reaction. So, this compound will not undergo hydrolysis. And the third chemical property like halogenation we can take. So, what is halogenation means? Introduction of a alkyl group. So, if I am taking nitromethane like CH3NO2, this is nitromethane. This nitromethane undergo halogenation. What is the meaning of halogenation? If I am adding chlorine in the presence of any base like NaOH, instead of NaOH you can use KOH also. Now, what happened? So, here what is alpha hydrogen we know, that is the functional group containing carbon, that is the functional group attached to carbon. If it contains a hydrogen, that is named as a alpha hydrogen. So, here it is having how many hydrogen atoms? 3 hydrogen atoms. So, all those 3 hydrogen atoms are replaced by a chlorine, you will get CCl3NO2. Because I have replaced all the hydrogen by a chlorine. Now, what happened to the hydrogen? That should be eliminated, and that should be eliminated not as like that, that is HCl, that is HCl. So, CCl3NO2 that should be added with and side product HCl. Now, what happened? So, what is its name? That is trichloronitromethane. Trichloronitromethane, because why? CH3NO2 is what? Nitromethane, where I have replaced all those 3 hydrogen atom by how many 3 hydrogen atom by 3 chlorine. So, you will get trichloronitromethane and side product as HCl, and one more name I am going to give, that is special name chloropicrane. What are going to see? Aromatic nitro compound, that is nitrobenzene. How to prepare nitrobenzene? That is by using nitration of benzene, you can prepare a aromatic nitro compound. Aromatic nitro compound. So, if I am taking benzene, so benzene you know C6H6. C6H6 benzene. Benzene on nitration. So, how to use nitration? Because nitration means the electrophile used is NO2 plus. But how did you get this electrophile? This electrophile you are going to get from those 2 reagents. One is concentrated nitric acid and concentrated sulfuric acid. Concentrated HNO3 and concentrated sulfuric acid. These 2 mixture combined only will get, the name of this mixture is nitrating mixture, and this gives the electrophile NO2 plus. Now, what happened? Always you know that a benzene ring is a electron rich center. Why electron rich center means inside the benzene ring, here there are 2, 4, 6, there are totally 6 electrons are revolving inside the benzene ring. On the whole, this benzene ring is electron rich. Electron rich, that means a negative part. So, always negative part will approach the positive electrophile, and you are getting the product benzene with attacking electrophile NO2. So, you are going to get nitrobenzene. But this nitrobenzene preparation will not occur at room temperature. We should apply the temperature as 330 Kelvin. This is a method of preparation of a nitrobenzene. Coming to chemical properties, once again if I mention about electron rich center. So, this will be acting as a nucleophile where you will expert the electrophilic substitution reaction. So, I can take the electrophilic substitution reaction. What is the meaning of substitution? You know, we are going to substitute. What is the electrophile? A species with a positive sign as an electrophile. Okay, now So, electrophilic substitution, I can use the electrophilic substitution as one is I can take nitration and another one I can take halogenation, nitration, halogenation, and we can take about sulphonation also. Sulphonation. Suppose if I am taking nitration, already this is nitrobenzene. Nitrobenzene. Okay. If I am taking nitration in the presence of concentrated H2SO4, concentrated HNO3, it gives a electrophile NO2 plus. Already in nitrobenzene 1 NO2 group. What is the nature of a NO2 group? This is acting as a deactivating group. That is deactivating group. So, the incoming electrophile will go and add in the meta direction only. This is a condition, meta direction. We don't know what is meta direction means. There are three systems. One is 2 ortho system available, 2 meta system available, 1 para system. So, you will get meta substituted product. Suppose first nitration, I can do the nitration in 2 different temperature. Suppose if I am taking 373 Kelvin, there is one type of product, that is I will expect the product as benzene ring, NO2 as nitro compound, and third position you will get one more nitro group attached. Nitrobenzene on nitration will give 1, 2, 3, that is 1, 3 dinitrobenzene as a product. Same way, if I am taking the same nitrobenzene as one product, that is reactant, if I am applying the condition, suppose if I am raising 100 Kelvin extra the temperature, you will get some other product. The product is NO2, that is first position and third position and fifth position. Those 2 meta positions are occupied by the nitro groups. The name is 1, 3, 5 trinitrobenzene. Trinitrobenzene. Like I can take a halogenation also. Halogenation means if I am taking the nitro compound, halogenation means just introduction of any halide group in the presence of AlCl3, that is in the form of anhydrous aluminium chloride. Anhydrous aluminium chloride, just I am going to introduce one Cl, that too in the meta position. So, you will get this nitrobenzene NO2 group and the meta position 1 chlorine. So, 3-chloro-nitrobenzene, the name for this compound is 3-chloro-nitrobenzene. 3-chloro-nitrobenzene. Same way, if I am taking sulphonation. Sulphonation means if I am taking nitrobenzene, like if I am using the reagent H2SO4, the electrophile SO3 should be added, that is SO3H in the form. So, the meta position NO2, the meta positions are occupied by a sulphonic acid, that 1, 2, 3 like that. Okay. So, if I am taking this compound, this is sulphonic nitro derivative, sulphonic nitro derivative. So, electrophilic substitution I can do nitration, halogenation, sulphonation etc. But you should remember for nitration alone 2 different temperature, remaining thing you can write based on the meta directing group. So, on the whole today we have discussed about what is nitro compounds and what are all the classification of nitro compounds, and if you are taking the nitro compound classified into aromatic and aliphatic system. First we have seen aliphatic nitro compound preparation, physical property and chemical property, and aromatic system also we have prepared nitrobenzene. Into for that also we have discussed about chemical property, that is electrophilic substitution. So, reaction. So, from that you can get what is the functional group nitro compound, what is the general formula RNO2, how do you give a IUPAC name of the system, what are all the conversions possible, what is primary nitro compound, what is secondary nitro compound, what is tertiary nitro compound, and based on how will you convert nitro compound to aniline compound, nitromethane to methylamine compound, and nitromethane to acetic acid or nitromethane to acetone, like that conversions you can follow. I hope that you have followed this class, and don't skip the class, as it is from the first to the last you go through it, and it is a equation. So, you should write then and there, and you can clarify with your teachers also. Thank you for the class.